Hello. In this video, we're going to look at a Microsoft reference architecture for hybrid identity. Now, in plain English, what this means is that this is how a company connects its traditional on-prem Active Directory to modern cloud applications in Azure. The idea is simple. Instead of rebuilding every user account from scratch in the cloud, what the company does is keep its existing identity system and then connects it to Microsoft Entra ID. This allows Azure applications to use the same corporate identities for sign in. Now, this diagram represents the complete solution, but what I want to do is break it down step by step in layman's terms. Now, if we start on the left side of this diagram, we can see the on-prem environment. This is where Active Directory lives. Now, Active Directory is the internal directory that a company uses to manage its employees, usernames, groups, account status, all that fun stuff. Now, also on-prem, you can see we have Microsoft Entra Connect Sync. Now, what this is the bridge between the local on-prem AD and Microsoft Entra ID in the cloud. Its job is to synchronize the identity information from the on-prem Active Directory into the Entra ID tenant. So, for example, when a new employee gets added, or when someone changes departments, or when an account gets disabled, these changes can be reflected in the cloud as well. That's what makes this a hybrid identity setup. The on-prem directory is still the source of truth, but the cloud is using a synchronized version of that identity data. Microsoft describes Entra Connect Sync as the on-prem service that synchronizes information stored in local Active Directory with Microsoft Entra ID. Now, in the middle of the diagram, we have the Microsoft Entra tenant, or essentially Entra ID. Think of this as the cloud gatekeeper for authentication. Instead of every application trying to manage its own usernames and passwords, the app hands off the sign-in to Microsoft Entra ID. The user authenticates there, and then the application gets the identity information it needs. That matters because once Entra ID is handling authentication, you can layer in modern cloud identity controls, things like multifactor authentication, conditional access, and identity monitoring. So before someone ever reaches the application itself, you can already be evaluating things like, is this login coming from a trusted location? Is the device compliant? Does the sign-in look risky? Microsoft explicitly recommends things like conditional access, MFA, and monitoring for suspicious activity as part of this and most other architectures. Now let's move to the right side of the diagram. This is where the application is running in Azure. The app shown here is displayed as what's called an N-tier architecture. Now, that just means that the application is separated into layers instead of being built as one just giant monolith. In this case, you can see we have a web tier, a business tier, and a data tier. Now, that separation is common because it gives you better control over scale, management, and security. Microsoft describes these VMs that support scalable, resilient, and secure applications by separating workloads into individual tiers like web, business logic, and data. The diagram also shows load balancers, it shows network security groups, and a management subnet with Azure Bastion. Now, the Microsoft diagram doesn't spell out every packet flow rule in detail, but in architectures like this, the layered network design is often used to create tighter security boundary between application tiers. Now, here's how this often happens in practice. Generally, traffic will enter through a front-end layer first. That's often through the load balancer. And in many real-world deployments, sometimes an application gateway might be the entry point or some similar ingress component, depending on the design. From there, the traffic gets sent into the web tier, which is the public-facing part of the application. In architectures like this, the network security groups, or NSGs, are usually configured so that the web tier only accepts the kind of inbound traffic that it actually needs instead of allowing broad access from anywhere. So basically, it just allows HTTPS, for example. Then behind that, you have the business tier, and that's usually not exposed directly to end users at all. A typical pattern here is that it only accepts traffic from the web tier, so users can't just skip that front end and hit the application logic directly. It's a protection layer. And then behind that, you have the data tier, and this is usually the most locked down layer of all. In most designs, or maybe I should say many designs, maybe not most, this tier only accepts traffic from the business tier. This helps keep the database isolated from both the internet and the front layer. So while the diagram itself is focused on hybrid identity, the tiering and NSGs shown here also align with a typical defense in depth pattern. Each layer only talks to the layer it actually needs to talk to. That's one of the main benefits of splitting the application across tiers instead of putting everything in one flat network. Now, you'll also notice the management subnet with Azure Bastion, and that's here for administrative access. Instead of opening up broad remote access straight to application servers, architectures like this will often use a controlled management path so administrators can reach systems more securely. Now, again, the exact operational model can vary, but the presence of a dedicated management subnet is usually part of keeping administration separate from user traffic. So with all that said, let's put this together. Let's walk through what happens here. In this type of architecture, a user tries to access the Azure-hosted application. Instead of the app handling sign-in directly, it sends the user to Microsoft Entra ID. Entra ID already knows about that user because their identity was synchronized from the company's on-prem Active Directory. The user signs in, Microsoft Entra ID verifies the identity, and then sends the user back to the application with the appropriate identity information. At that point, the request moves into the Azure application stack. And in a design like this, it often moves through multiple layers of control. Identity checks at the front door, and then layered network boundaries between the web, business, and data tiers. So the value of this architecture is not just that people can log in with their familiar corporate accounts. It's that the organization can keep its existing on-prem directory as a source of truth and then extend that identity into the cloud with Microsoft Entra Connect Sync. And then let Microsoft Entra ID handle authentication for their Azure applications. And around that identity model, the Azure application is often built with a layered network design that supports stronger separation between tiers and better defense in depth. So this architecture is really doing two things at once. It modernizes identity, and it supports a more secure way to structure cloud applications.